Here, this is an area of which this point C is centroid, and from this centroid I have drawn one axis, x-axis, and this axis is called centroidal axis because this axis is passing through the center of this area. If suppose I know the value of moment of inertia of this entire area with respect to this centroidal axis, then I can determine moment of inertia of this particular area with respect to any axis which is parallel to this x dash axis. For that I use parallel axis theorem. Now for that, let us assume one axis x-axis which is parallel to this x dash axis, which is passing through the centroid of the area, and we know by definition moment of inertia of this entire area, this moment of inertia of this entire area with respect to this x-axis which we want to determine. This can be obtained by taking a small area dA, and we know that its distance is from x-axis, its distance is y. So by definition, moment of inertia with respect to x-axis is given by integration of y square dA, that is distance of small area square into small area dA. Now here you can see that this y is equal to y dash. Y dash is the distance of this small area from x dash axis, and d is the distance between these two parallel axes. These are the two parallel axes, and d is the distance between these two parallel axes. So you, in place of y, you can write y is equal to y dash plus d, because d plus y dash is equal to y. So now replace this y square by y dash plus d square into dA. Now simplify this. By simplifying this, you will be getting this. Now here d is a constant value. Only variable in this equation, only variable is y dash. So again, separate them all. So integration of y dash square dA plus d square I have taken out because it is a constant value, integration of dA. Now 2d I have taken out, and this integration of y dash dA. Now out of this, integration of y dash square dA is moment of inertia with respect to x dash axis, because by definition we know that distance is square into small area and its integration is the moment of inertia. So y dash is the distance of this small area from this centroidal axis, and therefore this equation is moment of inertia of this entire area with respect to x dash axis. So I dash xx. Now integration of dA, integration of, if you integrate this area for this whole area, so you will be getting entire area of this given figure. Now 2d is the distance. Okay, integration of y dash into dA, y dash into dA, that is small area and its distance. This is first moment. Now we know that first moment with respect to x dash axis. Now we know that first moment with respect to any centroidal axis is 0, because this is calculated using formula A, integration A, this entire area, into distance of this entire area from this axis. So for taking distance, we take distance of center of this entire area from x dash axis. Now since x dash axis is centroidal axis, it is passing through the centroid only, therefore its distance will be 0, and therefore this integration of y dash dA will be 0. So finally you will get Ixx is equal to I dash xx plus a into d square. Now Ixx, this x-axis which I have taken here is taken arbitrarily. So you can replace this x in place of x-axis. You can write equation in this way: I is equal to I dash plus a into d square, where I dash is the moment of inertia of an area with respect to any axis passing through centroid. It may be x-axis, or it may be y-axis, or it may be any axis like this, or it may be any axis like this. Moment of inertia, I is the moment of inertia of an area with respect to an axis parallel to the centroidal axis. So if you are taking vertical y-axis, then parallel axis will be, I will be with respect to any other axis which is parallel to this. A is the area of given figure, and D is the distance between two parallel axes. Now here you can also see that I dash plus A into D square. Now value of D can be positive or negative, but square of this D will always be positive. Now you know that value of area is always positive. So this entire term is always positive, and therefore moment of inertia with respect to any axis, any other axis which is not centroidal axis, will be more than the centroidal axis. That means the axis which is passing through the centroid of centroid of an area, at that axis moment of inertia will be minimum. Suppose if I want to determine moment of inertia of this area with respect to an x-axis, any x-axis, for which the moment of inertia is minimum, then definitely that axis will be this axis, because any other axis if you take upside or downside, any axis you take, its value will be more than x dash axis. Let's take one example. This is a rectangle. Now I want to determine moment of inertia of this rectangle with respect to this y-axis, and another y-axis which is passing through the centroid, that is centroidal y-axis, about which we know the moment of inertia of this rectangle is bh cube by 12. So I know moment of inertia with respect to this axis, that is bh cube by 12. Now I want to determine moment of inertia of an axis which is parallel to this axis and passing through one of the sides of the rectangle. So this is rectangle, so it is passing through the one side of the rectangle. Now from the equation, Iyy is equal to I dash yy plus a into d square. Now I dash yy is equal to, we know that bh cube by 12. So bh cube by 12. Remember, I always say that I with respect to centroidal axis of any rectangle will always represent as bh cube by 12. B is the side which is parallel to the axis, and h will be the other side. Now area of this rectangle area, length into breadth, from that you will get b into h. Now d is the distance between these two parallel axes. Now we know that the center is at a distance of, if this total length is h, then this distance will be h by 2. So d is equal to h by 2. Now put all these values here. When you put all these values, bh cube by 12 plus bh into h by 2 square, so you will finally get Iyy is equal to bh cube by 3. So moment of inertia of rectangle with respect to any of the sides, I have taken this side, you can take this side also, it will always be bh cube by 3. Only you should remember that b is the side which is parallel to the axis, and in that way you can determine moment of inertia of this rectangle. Thank you for watching this video.